Hello everyone, I'm Hongliang from Jinan University. Today my topic is the response of atmospheric processes and pollutants to passive emission reductions during the COVID-19 episode in China. So air pollution control is a very complex system engineering. So in different locations, air pollution depends on the meteorology conditions, the emission, the terrains, and the species we are looking at. So there are multiple factors, but one solution is to control emission, to control air pollution is the emission control. So we have experience from developed countries who have been through this process for half centuries. And we also have a lot of experience from China due to the APEC blue and the parade blue in China. And also this year we have the great experience of the COVID-19 effects. A lot of countries has experienced the air pollution reductions due to the passive emission reductions. So due to this, the emission control strategies are very important. We can know that the emission control strategies, since in China, give us a very good example. Since the air pollution prevention and control action plan, the PM2.5 reduction in China, is accompanied by ozone increases. So it's very important to how to reduce one pollutant while not allow another one to increase too much. So also during the COVID-19, significant decrease in air pollution is not universal, in everywhere. We also see reduction in some pollutants, but increases in other pollutants. This is due to the air pollution. The changes of air pollutant concentrations are due to local emissions, regional transport of air pollutants, atmospheric processes, and meteorology conditions. So effective control strategy should consider all the factors instead of some of or only one of them. So in the right part of the slide, we have a very good example of the ozone isoplus, so which shows how ozone concentrations are controlled by both NOx and VOC concentrations. So if you didn't consider the VOC limited area or the NOx limited area, you probably will have trouble in reduce ozone concentrations. So this COVID-19 caused a lot of problems, but it also provides valuable opportunities for air pollution control, especially for future studies. So there are a lot of passive emission reduction, mostly from transportation, because people stay at home and reduce their unnecessary activities. And this is also nationwide in all the countries and internationally. So in many countries, we have observed changes in air pollutants. This slide shows that the changes of air pollutants in China. So we can see that in Shanghai, Hefei, Hangzhou, and Nanjing, for major cities in the Yangtze River Delta, we can see PM2.5 concentration decrease since the pre-lockdown period to the two different levels of the lockdown episodes. We can see significant reductions in PM2.5 concentrations at the most by almost half in Nanjing, for example. Also, we can see that from a recent study from my group, so we have looked at the changes of ozone concentration during the lockdown episode. In contrast to the PM2.5 concentration decrease, ozone increased in a lot of areas, including the three major areas, the North China Plain, the Yangtze River Delta, and the Pearl River Delta. So we also we can see that in different regions, the changes are different. In the Yangtze River Delta and the North China Plain, so we can see increase of ozone, while in the Pearl River Delta in Guangzhou, we can see very limited changes or even reduction of ozone concentration. So this means that the pollutant changes are different in different locations. So this things also observed in India. We can see that compared to previous 3 years, 2017, 2018, and 2019, the pollutant concentrations in different regions of India all reduced, including PM 2.5, CO, NO2, and SO2. But we didn't see continuous reductions of ozone concentration, but some increases some in different regions. So this is also due to that the complex atmospheric processes, in addition to the reduction of the emissions. Other countries, for example, this should be Italy. Okay, so in Italy, we also see that reduce of the NO2 concentrations. And we also look at all the countries. We have looked at since for the March of since 2015 to 2020. We can see that in all those countries, PM 2.5 actually has a decrease, especially in March 2020 due to the COVID-19 processes. However, ozone does not change the same way. So during the COVID-19, so ozone concentrations in some countries increased. For example, China and Korea. So in San Francisco, we also see that ozone has an increase of 11%, while other pollutants reduced by more than 16%. And especially this is ozone increase. People think it's related to NOx reductions. So this tells us that it's not only the reduction of emissions cannot only result in reduction of pollutants, but for some pollutants it might increase the concentrations. So so here we use China as an example. So emission changes during the COVID-19 for two reasons. One is actually it's a spring festival for the COVID-19 processes. However, the changes were much larger than previous years. Previous years for the spring festival, people also go home and go to their hometown and reduce a lot of activities during the holiday season. However, this year due to COVID-19, the emission reduction are much larger than previous years. So here's the example we have from the changes of population and traffic volumes in Shanghai. We can see that compared to previous years, the amount of vehicles and human population has been changed a lot. Also, there's a satellite data shows that the NO2 concentrations, compared to from January to February, which were pre-lockdown and the COVID-19 lockdown process respectively. So all these have been estimated by scientists, and we have applied these factors in our studies to look at to simulate the changes of air pollutants. So we have set up 3 cases. In case 1, we assume there's no changes of emissions. So all the change as a base case. So for case 2, we have a medium level changes of air pollutants. So in the whole country of China, transportation was reduced by 40%, industrial by 20%. However, due to people stayed at home, residential related activity actually was increased by 10%. Well, there's no changes in agriculture and power supply. So in case 3, we look at the 2 different, we look at the 2 regions. One is the Hubei province, which is the center of the COVID-19 processes. And the lockdown reactions, lockdown measures are much strictly than other areas. So we have in industrial was reduced by 80% from and agriculture process also reduced by 80% in Hubei. While in other areas, the industrial is only reduced by 20%. So let's look at the simulation results. we can see that for the PM2.5 and all the major components of PM2.5, due to the lockdown, so case 2 and case 3, we have seen that the primary components, all the components are reducing, except due to in the case 2, the residential emissions are increasing. So black carbon, the elementary carbon, and the primary organic aerosols from this was increased. This is actually correlated well with the emissions. So we can also look at the figure in the right. We can see that in all the major cities in China, we can see that in different cases, the pollutant day and the non-pollutant day. So we can see that the changes of the model are doing very well in reproduce the observed concentrations, and we can also see the changes due to the lockdown processes. So what are the changes? What are the reasons for the changes in air pollutants? Obviously, emission changes are the direct reason. However, so we should also look at other factors, like I mentioned in the first few slides. So here we separate the roles of the meteorology and the emission changes. So here we show that is the direct role of the meteorology. So because the meteorology conditions change, so the emission change does not always result in the same, changes in the concentrations. So here we can look at that in Beijing, on the left we have actually the changes of the emissions, primary PM and elementary carbon, organic carbon, and the precursors to PM2.5, SO2, NOx, and VOCs. Then we can also look at the change of the PM2.5 components. We can see that the ratios of the changes in components in the concentrations of PM are much smaller than the changes in the emissions. This is because the emission, the meteorology plays an important role, so that although you reduce a lot of the emissions, but you didn't see the same level of reductions in concentrations. Similar cases can be seen in all cities we showed here: Wuhan, Guangzhou, and Shanghai. So we also look at the changes due to the meteorology and due to the emission in different ways to the total PM2.5. We can see that actually the meteorology actually in the COVID-19 episode in China actually plays a very important role, that if there was no emission reductions, actually the PM2.5 concentration can be increased by up more than 60 microgram per cubic meter in Tianjin, and more than 40 in many cities. Only in Jinan and Wuhan, there's no direct effects. However, the emission changes actually have some roles in the reduction of the pollutants. However, it was much smaller than the changes due to meteorology. So we see that in this episode that even emission was reduced a lot, the concentration still increased. So so there are the other reasons for the changes. It's actually there's the aerosol and the meteorology interactions. So we have a lot of aerosols. The aerosols, the pollutions actually can block the solar radiation and reduce the dispersion of the air pollutants. So this is due to the very complex aerosol and meteorology interactions, including the direct effects and the indirect effects. So aerosols can act as cloud condensation nuclear and ice nuclear. However, currently there's a lack of studies. ZHANG et al. In the dual research letter is that they look at the ratios, of pollutants changes due to the aerosol meteorology interactions in China. So it can be, as large as 40% in some locations. So the other things I think is the atmosphere processes. So when you have the changes in the emissions, actually the atmospheric process has been changed, especially the chemical reactions. So one of our studies that has been in preparation is look at the when you have the reductions of NOx, especially NOx from vehicles, and actually the atmosphere oxidation capacities increase. So so this is actually an indicator for the major oxidants in the atmosphere, including OH and NO3 and ozone. So here we look at their concentrations of OH, and it's very well related with the ozone changes in China. And also if we look at their sinks and the sources of those oxidants, we can clearly see that in case 2 during the lockdown, actually they were increased. So in addition to that, another atmospheric process change is that the ozone formation regimes. So ozone can be related, ozone formation is limited by either VOC or NOx or both in the atmosphere. So during the COVID-19 processes, the ozone regime actually has been changed. We have looked at our model simulation and the satellite data to look at formaldehyde and NO2 ratios. Use this as the indicator. When this ratio is less than 1, we assume it's VOC limited. When this ratio is larger than 2, it's NOx limited. From this process, the plot here, we can see that during the lockdown and before the lockdown, during the lockdown, and after the lockdown, we can see that the ozone formation regime changed a lot in a lot of areas. Although there shows much different results from the satellite and the simulation, but the same idea is here, that the ozone formation regime has been changed in addition to the oxidation capacities. So this is my last slide about the implication from this. So due to the complex formation of air pollutants, emission changes cause different responses of air pollutants. So due to COVID-19, the large reductions from transportation has led to reduction of particulate matter and increase of ozone in many locations, including China. So if we consider the meteorology and atmosphere processes, we should consider them. Okay, they are very important for future pollution control strategies. So in summary, balanced measures are highly recommended, especially when we look at PM 2.5 ozone at the same time, because NOx and VOCs are both precursors to both PM and ozone. So we should consider them at the same time. Also, we should consider climate change for future cases. So that's all. Thank you.